Hello, today we are talking about coercion and casting. So, what is coercion and casting? What does all that mean? So coercion is just a broad term that means we're going to take one data type and we're going to convert it to a similar data type. So for example, if we have an int a equals 10, if I say double b equals a, and you see it does this no problem, and I can sys out b, and if we run it, we get 10.0. So it's an easy coercion. All we had to do was tack on a 0.0 at the end of our int, because we're not losing any data converting an int to a double. Casting, however, is a specific type of coercion when we need to tell Eclipse or Java, hey, I want you to take this double and convert it to an int. So let's reverse this. Let's say double a equals 10.0, and let's convert that to an int. Now there's a problem, right? Type mismatch cannot convert from double to an int because we're losing data, even though we know it's just 0.0, right? We can see that. It's common sense. We're not actually losing any data, but Java doesn't know that. What if this was 10.9, right? Now we're suddenly losing almost 10% of our data. So this is why we have this type security in place. So, as you can see, it says add cast to int. So we're going to cast our double a as an int. That just means we're going to put some parentheses in front of it and then put the new data type that we want to convert it to. So this is explicit. What we had before when we converted an int to a double was implicit, meaning it did it behind the scenes. Here we have to be explicit with telling Java, hey, I know I'm going to lose data, but I want you to convert this to an int. So if we run this, we just get 10, right? Even though it was 10.9, there was no rounding. All it did was truncate it. That just means it got rid of the decimal point and everything after it. So it could be 10.9999999, so on and so forth. Run it, it's still going to be 10, no matter what. This is the essence of casting. So we're just taking one data type and converting it to another like data type. There's also something called parsing, which is very similar, and that's converting two non-like data types. So for example, if we have a string, and I'm going to call it num and set it equal to 123. And then I'm going to take this and convert it to an int. Well, if I just say int a equals int num and I try to cast it like that, well, this isn't going to work, because we cannot cast from a string to an int. They're not like data types. So instead, we have to parse it. Parsing basically just means we're taking some value and we're going to try to read through it and glean some other values out of it. So for example, in this case, we're going to read through the string 123, and we're going to try to get this data 123 as a number out of this string. So the way we're going to do that is we're going to say integer dot parse int, and then inside these parentheses, it's asking for a string, so we're going to put num. And there we have it, 123. So now, just to further prove this is a number, let's add 10 to a. So a plus equals 10, and we get 133. So now it's registering this as a number because we parsed it and looked for integers. Sure enough, we found an int, we converted it, we stored it in this variable, and then we can add 10 to it, do exactly whatever we want with an int. So some of you might now be wondering, well, going back to that int and that double problem that we had before, where we had double a equals 10.9, and then int b equals cast a as an int, and then we print out b. If we lose that 0.9, then how can we sort of save that 0.9 if we did want to convert it to an int, like if we wanted to round it per se? That's a great question, and I'm going to cover that in the next video, so stay tuned.